Hello, everyone. Today, we're going to explore one of the most fundamental parts of any computer, the operating system. We'll cover what an OS is, its history, how it manages storage, the input-output system, and the OS's internal structure. Let's get started. 1. What is an operating system? An operating system, or OS, is software that acts as an intermediary between you and the computer hardware. It manages all the hardware components like the CPU, memory, storage devices, and input-output peripherals. The OS also provides an environment so that application software can run smoothly without needing to directly handle the hardware. For example, when you open a browser or a game, the OS manages the resources needed, like processing power and memory, so everything works seamlessly. 2. History of operating systems. Operating systems have evolved significantly since computers were first invented. Here's a quick timeline. First generation, 1940 to 1955. In this era, there was no operating system. Programs were written in machine code and ran directly on the hardware one at a time. This was slow and inefficient. Second generation, 1955 to 1965. Batch processing systems were introduced where jobs were grouped and run sequentially with minimal human interaction. Simple OS software helped manage job queues. Third generation, 1965 to 1980. Multi-programming and multitasking systems appeared. This allowed multiple programs to run at the same time, improving CPU utilization. Unix, a key example, was developed in this period. Fourth generation, 1980 to present. Personal computers became popular and GUI-based operating systems like Windows and Mac OS took over. Mobile operating systems like Android and iOS also emerged. Fifth generation, future. We're now moving towards AI-driven cloud-based OS and distributed systems that integrate smart technologies. Storage structure of operating system. Primary storage, RAM. This is fast, volatile memory used to hold data and programs currently in use. When the computer powers off, data here is lost. Secondary storage includes hard drives and solid-state drives, SSDs. This storage is non-volatile, meaning data stays even when power is off. It holds your operating system files, applications, and personal data. Cache memory. A small, very fast memory between the CPU and RAM. It stores frequently accessed data to speed up processing. Registers, tiny storage units inside the CPU itself, used to hold data and instructions the processor is currently working on. The OS manages data transfer between these types to optimize speed and efficiency. 4. Basic functions of operating system. 1.5. Process management. The OS creates, schedules, and terminates processes. It ensures each running program gets CPU time. Memory management. It allocates RAM to processes, keeps track of used and free memory, and handles virtual memory to extend RAM using disk space. File system management. Organizes data into files and directories on storage devices, manages file access permissions, and ensures data integrity. Device management controls all input and output devices like keyboards, mice, printers, and disk drives through device drivers and controllers. User interface provides a way for users to interact with the computer, either through command line or graphical interfaces. Security and access control protects data and system resources from unauthorized access and malware. 5. Computer system organization. Input-output structure. Let's look at how input and output devices fit into a computer system. Input devices, like keyboards, mice, scanners, they send data to the computer. Output devices, like monitors, printers, and speakers, they receive data from the computer to display or produce output. I/O controllers. These are hardware components that act as intermediaries between the CPU and the devices. managing data transfers. System bus, the communication channel that connects CPU, memory, and I/O devices. Interrupts, signals sent by devices to the CPU to get its attention, telling it to pause current work and handle the device's needs. This structure lets the OS efficiently manage all devices connected to the system. 6. Structure of operating system. Operating systems are built with different structural designs. Monolithic structure, all OS services like file management, device drivers, and process control run in a single large kernel space. This is fast but harder to maintain. Layered structure. The OS is divided into layers, each layer built on top of the lower ones. For example, the lowest layer manages hardware, the next manages memory, and so on. This makes debugging and maintenance easier. Microkernel structure. The core kernel handles only essential services like communication between hardware and processes. Other services run in user space, increasing system stability and security. Modular structure. The OS is made up of separate modules that can be loaded or unloaded dynamically. Linux uses this, allowing new device drivers or features to be added without restarting. Example: Linux's modular kernel lets you load new drivers as modules, improving flexibility and performance. And that was a detailed look at operating systems, from basics to architecture. If you found this helpful, please comment what topic you want next, and subscribe for more tech explanations. Thanks for watching.